Okay. Thank you. I see some of you joining. This is lesson 7, linear equations with more than one solution. Let's go to your course first and look at your learning target for today. So let's go back to here. Learning target, which is right here. And it tells us what we're doing today, why we're doing it, and how you'll know if you've been successful. Okay. So um, students need to understand that equations can have multiple solutions because it helps them accurately interpret and solve real world problems where there might not be a single definitive answer, allowing them to consider various possibilities and understand the limitations of mathematical modeling. It also helps deepen their understanding of the relationship between variables in an equation and how different values can satisfy it. You're going to work through a Nearpod together and individually to determine how many solutions an equation has. Students have some draw it slides. They will know they are being successful if they can fill out the draw it slides accurately. And also if you can communicate and chat and in the discussion and get the answer, learn the correct answers. Okay. All right. So next slide says identify the linear equations and one variable with infinitely many solutions. Identify in one variable and infinitely many solutions are equivalent to the equation A equals A. Solve linear equations in one variable and have only one solution. This lesson broadens students' understanding of linear equations to include equations with infinitely many solutions. Student, you're going to learn to recognize that encountering an equation that is always true during the solving process indicates that the original equation has infinitely many solutions. You're going to solve various equations with only one solution and with infinitely many solutions. So some partner activity will be done by you sharing with each other in chat. Okay, so I need to see your participation there. Please share with everyone. Yes, I did. How do you get in it? Okay, did you get did you go in chat for it? Here's chat. Here's the chat link for Nearpod. There you go. Good question. Okay. So I'm looking for participation. So we're going to start with this warm up, seeing what could you combine here. Kind of like, yeah, kind of like solitaire or other like card games where you combine things. Okay, so this should have been a draw it slide. Is this not a draw it slide? Doesn't look like a draw it slide. So in that case, just put it in chat. What do you think the first one is? It should have turned out like a dress. What would you do to simplify that? So I'm looking in chat to see. What would you do? Okay, thank you, Robert. Multiply 5 to the others. Yes. What do you get if you do that? What would you get? Can you put what you think would be the answer? Right, exactly. So it was contributed by a classmate. If you text me individually, that's fine. I'm not gonna say your name. I did say your name and you got it right, but in the future I won't. Okay. If you want to text me uh individually, I don't want you to feel like you can't do that. Okay. So let's let's go on to the next one. Can anybody tell me, can you combine those next two numbers? This is called simplifying. Uh, they're not equations because there's no equal sign there, but simplifying, we'll call them terms. Okay, so I've got some notes here. Yes, you could put them together. Right, exactly. It would also be 5x. You have 11x, take away 6x, and so that makes 5x. What would the third one be? Can anybody tell me? Oh, I did that just to Graciela, sorry. Yes, you're right, Robert. It would be 5x. Okay. What would come next? What would the next one be? And it's great that you're participating because then I know I learn your name as someone who's participating. That's good. Hello. Hey, Marcus. Are you new? So what happens when you combine 3x with negative 5x. We're all combining, supposed to be combining like terms. What do you get when you have 3x and a negative 5x? What is 3x take away 5x? Yep, good job. Good question. You combine the negative to get a negative 2x. Exactly. Negative 2x is correct. Negative 2x. And then what do you get for the numbers that don't have a variable? What do you do? What do you do for the numbers that don't? You've got a negative 10 and a negative 8. What does that give you? Perfect, exactly. Negative 18 was the answer given by student. And that's correct. So you'd have negative 2x, take away 18. What about the next one? 7x plus 8 plus 6x, take away 4. Okay. Another answer, 7x and 6x would be 13x. Perfect. And let me tell you, student who's telling me all this, I love to write a notes to parents and say, your student is awesome. 8 take away 4 is 4. That's right. So it'd be 13x plus 4. All right. What about the next one? Negative 6x, negative 8 plus 9x take away 4. What would that be? I didn't mean to put a down slash there. So don't be confused by that. Okie dokie. Anybody know? You have negative 6x and positive 9x. What does that give you? Okay. So exactly, that's 3x. And then what else for the numbers there? After this, I am going, yeah, take away 12, right? Because -8 and a -4 is going to give you a -12. Yeah, so that means that number 5 is 3x, take away 12. Okay, what about the last one? 5x plus 8. How do you multiply that out? I put that to just 1. 3x, take away 12. Okay, what do you do for the last one? And then I'll take attendance. You're going to have 5x, right? 5x plus 8, take away 2x plus, you have to multiply the -2. It's like you have to, it's two dance partners. It dances with x first, which gives -2x, and then it dances with -4 to give a positive. A positive 8, because you got a negative. It's going to be a positive 8. You see? You see that? And good that you're participating, because that's how you know if you're going to miss something, right? So you got positive 8 plus 8, that's 16, right? And 5x take away 2x, so that's 3x plus 16. And there we go, are the answers again. Okay. And it looks like my draw it slides didn't come out. So we'll just go over it together and let's see what did turn out. Like this did not show up, right? Or did you do it? Oh, you did do them. It did come out. Just this person didn't do it all. You know, you fill them out before you submit them, right? Thank you, Micaiah. Okay. I see you were working on them. Okay, so this person. Okay, good job. All right, that's the way to do it. Okay, I need to stop for a minute and take attendance. Go ahead and be working on this. And what you want to do here is substitute the 1 in each. See which numbers make the statement true. Like if you plug 1 in for W, would that be true? Would that side equal this side? I'll do one of them before I take attendance. Like if I plug the 1 in there, I get 8 plus 5. And if I plug the 1 in here, it'd be 5 plus 8, which is the same thing as 8 plus 5. So yes, W could be 1. What about 2? If I put a 2 in here, that gives me 16 plus 5. But I put a 2 in there, it gives me 10 plus 8. So no, that wouldn't work there. Same thing with 3. Well, 3 times 8 is 24. Okay, well, let's make sure. Wait, 16 plus 5 is 21. And if I put a 2 in here, that's 10 plus 8. Yeah, so it's not the same thing. What if I put a 3 in there? 3 times 8 is 24 plus 5, that's 29. And then 3 times 5 is 15 plus 8 is 8 plus 5 is 3, that's 23. So no, it can't be that one, 2 or 3. What about 4? What if I put 4 in there? If I substitute 4 for 8, I get 32 plus 5 is 37. If I substitute 4 here, That's 20 plus 8, that's 28. So no, the only place that works, the only solution that makes that equation A true is if W is 1. The only solution of those given there. Okay, so go ahead and be working on that while I stop sharing and do attendance. So I see I have Aaliyah here, Aaliyah, Devin, Graciela, Micaiah, Quincy, Robert. Let's see. Yeah. So let me do attendance. So Aaliyah's here. Don't see Isaiah's. I don't think I saw Narita. Okay, so that's what we found out. What about for B? What about solution 1 for B? How about substituting 1 in here? And does it make the statement true? If I put a 1 in here, that's 6 take away 4, which is 2, and you multiply 2 times, you multiply 2 times 1/2, right? And you get 2 halves, which is 1, and that's not equal to 7. So no, it's not equal to there. What about if I put a 2 in here? Does that equal 7? Can anybody guess what's going to be the solution? Can you look at it and tell? Will it be 2? Will it be 3? What do you think? It's going to need to be a number that gives you. Okay, so if I put in, thank you for contributing that. So let's try that out. If you put 2 times 6, that's 12, right? Take away 4, you need it to be 14 in order to multiply it by 1/2 and get 7. So what number would you have to put in there? What would happen if you put a 3 in there? What's 3 times 6? It's 18, right? 18 take away 4 is 14. So it would be here. Okay, what about this one? If we put a 1 in, that's going to get 4 plus 3 times 7 times 3, which is 21. It's 7 times 3, that's 21. 12 plus 9 is 21, so it works there. What if I put a 2 in it? That gives me 8 plus 3 is 11 times 3, that's 33. And if I put a 2 in here, that's 24 plus 9 is 33. So that works there too. Okay, so can you see that some solutions, some equations only have one solution, but here's an equation that has 2 solutions. What did I just say? Because that's something they wanted you to see and understand. So what is it that I just said? Who can write what I just said? It's the whole purpose of what they want you to understand in this lesson. I'm going to say it again. In fact, I'm just going to type it out. Okay. So they want you to understand that some equations have one solution while others have more than one solution. Okay. Well, all right, let's look here. So in fact, equation C worked with every single one. We did check, we did this one and we did that one, but also 3 would work. It says 2 works. 8 plus 3. Yeah, we did 8 plus 3. Oh, this has a 0 on it. Okay. We hadn't been putting a 0 in it. So we saw this one and that one works. And it also works in the same way with 3. All right, so here are some statements and questions to think about. What do you notice about your ending numbers? We're gonna skip that. Okay, so you have solved equations that only have one solution, or you have ones that have infinitely many. Of course, we don't know that they're infinite. Because students are solving linear equations, remember, we know it's linear because the variable doesn't have an exponent. Once it has an exponent, then it graphs something different. Then a line is therefore not called a linear equation. So they learn the possible number of solutions for a linear. When students have finished, use the following prompts. What do you notice about the values of W that make each sentence true? Equations A, B, and D have only one value of W that makes each equation true, but all the values given in the table make C true. We already noticed that. Do any values of W make C true? If so, which ones? Yes, a lot of the values did, right? Okay, here's the next one. So I'm going to explain it to you, and then this is supposed to be a draw it slide. Looks like it didn't come out as one either. But you can solve it in chat for me. So I'll make sure I go back and make the others draw it. All right, what did they do first? This is like what we had before. We got to this place. They multiplied it out, right? 3 times 4W gives you 12W. 3 times 3 gives you 9. Okay, look, they are the same thing. 12W plus 9 equals 12W plus 9. So you can't solve it, because what happens is when you take away 12W from both sides, then you lose the variable, because that takes that away and gives you 0, and you're just left with 9. Take away 9. Okay, so now you do the same thing. I took away the page. I'm looking in chat to see, can you solve this? I would be looking on my draw it slide, but and for anybody else listening to the recording, then I will be able to look at it there. All right. Anybody gonna write it down for me? Tell you what, I'm gonna go ahead and go through it, and then I'm going to look at my slides and change them to make sure you have drawn slides and give it back to you. After applying the distributive property, some students may recognize, this is what I was talking about. When you distributed the 12W, it turns into 0, and you're left with 9 take away 9. You can't solve that one. There is no, actually it has an infinite number of solutions, because no matter what you put into it, it's going to subtract on the other side, and you're going to have 9 equals 9. So both the what are the equation that equation have in common? It has the same thing on both sides. They're the same. And how do they differ? Some equations still have a variable and some do not. So there are other equations like that. Recall that as we are solving an equation, the properties of equality ensure that the equation we write at each step has the same solution. Are each of these equations always true? 9 equals 9, 0 equals 0. Yes, right? They're always true. 9, like I said, 9 cannot identify as 10. 9 is 9. Okay. 0 is 0. So you can count on that. You can take it to the bank. These equations are true for any value of W. What does it tell us? About equation C, that equation C is also true for any value of W. Like I said, no matter what W is here, the equation has infinite solutions because there are an infinite number of values that make the equation true. Remember, when you multiplied this out, you got 12W. No, you got 12 plus, you got 12 plus 3W equals 12W plus 9. We did this one in the other part of the equation, right? In the chart. Okay, let's move forward. Okay, for problems 3 through 6, find the number of solutions to each equation. All right. 3x take away 9. When you solve that, you get -9 equals -9. This would have an infinite number of solutions also, right? Because if you put a 0 in there, it's still this 0. This is, they're going to take away from each other, and you're going to be left with -9 take away -9. -9 equals -9. So that has an infinite number of solutions. What about this one? You're going to end up with V equals 2/3. V equals a -2/3 because you multiply this out and get 9V plus 3. And then you combine, when you take the 6V from 9V, and you get 3V, and 3 over here, you get a -2. Okay, over here, this is the same thing. It's followed through. The equation has only one solution. Okay, we're able to solve that and find the one solution. Okay, and here is one that I just did for you to do. It actually does have a draw it slot, apparently. Where'd it go? There it is right there. Okay, so for the last part of this class, we do have a draw it slide. So I want you to finish that, and I have